Hello. Yeah. Am I audible properly?
Yes, sir.
Okay, fine. So, good evening to all of you.
Good evening, sir.
Everyone is ready for enter. The preparation is still going on.
Yes, sir.
So, fine, fine. So, you have 1 week. Okay. Okay, so I will start. Okay, so what's the agenda of today's session? I will cover the. We will discuss the concepts of week 9 and week 10. Okay. So first we'll try to cover the content of week 9 and week 10. And on Tuesday, I mean, day after tomorrow, there is one more session, revision session for week 11 and week 12. So most probably that session will be taken by Usama. Okay. So, okay. So just give me a minute. I will share my screen and we'll start this. Okay. So can you see my screen? Is my screen visible?
Yes, sir.
Okay,
Sir.
fine. Okay, so before starting, let me give you some idea of weightage for your end term. Okay, marks. I mean weightage according to marks. Okay, so weightage is as we initially told to all of you, major portion will be from week 9 to 12. So let me give you week wise. So basically from week 9 to 12, there will be 55%. Okay, it will cover 55%. And 5 to 8, it will cover, still it's approximately equal to 55. And it will be approximately, some 27.5, I mean 28% basically. And 1 to 4, it will cover basically rest 18%. So 18, or you can say basically it's something 17. So more or less, basic thing is that 1 to 8 will cover 45%. Okay. And remaining 55% will be from week 9 to 12. Okay. So these are the your weightage for your end term exams. Okay. Okay, so let's start the content of week 9 itself. Okay, so in week 9, so till week 8, what are the things? Okay, from the initial weeks till week 4, we have discussed something categorical data, numerical data, right? Discrete, continuous, and some association between categorical, association between numerical, association between categorical and numerical. Then we move to the counting principle, then probability and all, right? Now in week 9, we are going to study about random variable, basically. So, what is the random variable? First of all, before moving to that random variable, so can you tell me what is the sample space?
Set of all outcomes.
Set of all outcomes,
A set of all outcomes.
all
All
outcomes
possible outcomes.
of a random experiment, right?
All
Yes.
possible outcomes.
Yes,
All
sir.
possible outcomes. Right? This is sample space. Okay, suppose I'm going to do experiment. I'm going to rolling a die. That's a 2 times. Okay. For example, I'm rolling a die 2 times. Then what will be my sample space? It will be 1 1. It can be 1 2.
36.
So 36 is the counting, right? I'm asking about I mean sample space. It will be 1 5 1 6, right? So similarly, 2 1 2 2 6, right? Similarly, up to, if you see, it will be 6 1 2 6 6, right?
1, 2, 6.
Correct. So these
Yes,
are
sir.
the set of all possible outcomes if I'm going to roll a die 2 times. Correct. Now,
Yes, sir.
so this is your sample space while doing this experiment. Now, why the notion of random variable introduced? So first of all, suppose I'm not interested in all the outcomes. Okay. Suppose I'm not
Okay.
interested in all the outcomes, but I'm interested in, let's say, some specific thing. I'm saying what will be the possible values when I'm interested in, let's say, sum of both number, I mean sum of the numbers is let's say greater than 8, right? So for this kind of scenario, I'm interested only the those possible outcomes where sum is greater than 8, right? I mean sum of the numbers will be more than 8. Yes or no?
Yeah.
So what will be those numbers?
Like 4, 4, 5, 3.
Can you repeat, sir, can you repeat from the definition of sample space?
Okay, so in sample space, what we are observing, in sample space, what we are saying, we are observing all the possible outcomes, right? Every possible outcomes we are collecting. Basically, this is collection of all possible outcomes, right? In the sample space, right?
Yes.
Suppose I'm not interested in all the possible outcome. I'm interested in some particular thing. Let's say I'm saying I'm interested in what is like sum of numbers. If sum of numbers is greater than 8, then what will be the possible outcome?
3, 5, 4,
9,
3,
2,
6,
3,
It
5,
can be
4.
it
sir,
can be
6.
it can be
3,
6,
6,
6,
sir.
5, 4, 5, 5, 4, right? 6, 3, and
Yes, sir.
6,
6,
4,
4, right?
6,
6, 5,
5, 6,
6,
6.
6, right? So basically something like this. Okay, let's say. Okay, so okay, let me take another example. Suppose, okay, I'm tossing a coin 2 times. Then what will be my sample space?
T, T, H, 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 T, T, T,
Head,
T,
head,
H.
T,
H,
T.
H, H, T, right?
Yes.
This is collection of all the possible outcomes. Now, suppose I'm interested in number of heads. Okay, number of heads. Then what will be the okay? Now for this, now in this case, I can't take all the possible outcomes. Right? I mean the I will what will be the values for this scenario? If you are interested in number of heads only,
0, 1, 2,
0,
H.
1, 2, right?
1, 2. Yes, sir.
Means number of heads means either here if you see 0 head, right? 2 head, 1 head, 1 head, right? So basically, I'm interested here. Basically, number of heads, right? Similarly, okay. So in those kind of scenarios, so I'm moving with the
There should be 2 1 na here.
sorry. No, see,
There should be 2.
that's okay. I'm saying what is the possible outcomes this case will take. Either it will be 0, it will be 1, either 2, right? For this one,
Yeah,
there is these two are inbuilt, right?
okay.
Okay. So it's okay. I'm moving with the say, I'm moving with the actually example. I'm trying to move with the example. Okay. Okay. Are you getting my point? Basically. So what is the random variable in layman term basically?
Yes.
So yeah. So random variable is nothing but it's kind of you can say in this case we are assign a numerical value to each outcome in a sample space. Okay. In layman term, if I say we assign a numerical value to the outcome of or outcome in the sample space. Okay, I will tell you what is the meaning. We have taken the previous example, so that is the something will help you. So what we do, we are going assigning some numerical value to the outcome in the sample space. Now, so what this is the sample space, right? Correct. Now, if I
Yes, sir.
define, I will define a random variable, let's say x, as a number of heads is going to represent number of heads. Now, what we are doing for outcomes, we are assigning a number, right? For okay, number of heads means for this outcome, what will be value? It will be 0, right? For
Yes,
this
sir.
outcome, value will be 2. For this outcome, value will be 1. For this outcome, value will be 1, right? So at then my x will take value 0, 1, and 2. Yes or no?
Yes.
These are the possible values, right?
Yes, sir.
Are you getting my point? Okay.
Hmm.
So this is
Yes,
some
sir.
random variable. So if you move to the stage 2 part and all, so basically random variable is nothing but a function, but we are not moving. I mean, we are not going that depth. We are just going just trying to brush up the concept. Okay. So random variable is basically when we are not interested in all the outcomes, right? We are interested in some particular case. Okay. Let's say, what about, suppose I'm tossing the coin 3 times. Okay.
Okay.
Then what will be all possible outcome? It will be sample space will be simply, let's say, HH,
Sir, triple H,
HHT,
HHT,
STS,
HTH,
right? And then vice
THH.
versa. I mean, you can do like TTT, right?
Yes, sir.
TTH, right? THT and
THT.
STT, right? This is
Yes, sir.
sample space.
Yes, sir.
Suppose I'm defining a random variable x as a number of tails. Okay.
Okay.
Then now what we
Number
are
of-
doing? We are assigning a numerical value for outcome of the sample space, right?
Samples.
Yes or no?
Yes, sir.
If number of
Yes,
tails
sir.
you are interested, that means for this it will be 0. Right?
0.
And
0,
it
1,
will
2,
take value
3.
1, it can take value 2, it can take
Also
value 3, right? Right?
Yes,
So
sir.
these are the possible value this random variable will take, right?
X. Yes.
And accordingly, we will
Yes.
assign the some probabilities. I mean, for one, we'll take which one. I mean, for one, then we have to consider this case,
1/8.
this case, right? And these two, this case, right? Accordingly, we have to consider cases, right? So we'll move to the probability part little bit later. So basically, no, this concept is clear, right?
Yes, sir. Yes, sir.
Okay, let me move to the one. Okay, I have collected some questions from activity and all. So just read this question. Do let me know what will be the answer. So here, your random variable x is nothing but set of all possible values that x can
Option
take. I mean, this is the definition basically.
So option
Definition
C.
for what? Range. Okay. I mean, range is what? This is a range of any random variable, nothing but the set of all possible values that x can take. For example, here if you see this, here I will see what is the range of x. Range of x is nothing but
1, 2,
0,
0,
1,
1, 2, 3.
2, 3, right? What is this?
Yes,
This
sir.
is this all the possible values which this random variable can take, right?
Yes, sir.
Okay. Now, so let a random variable y be defined as the number of tosses until first head comes on a tossing a coin. Then what will be the range of y? So okay,
D
then,
1, 2,
option.
3.
sorry.
D option, sir.
Okay, I got one vote for option number D. Other
So option C.
Sir, C option.
So
C.
C1.
C.
Okay, I got some 2 votes for C. Okay, what will you first of all see? What is the y? Why number
So
of
here,
tosses required, right?
yes, sir.
So you need at least, actually answer C is the correct. You need at least one toss, right, to get the head, right?
First head come. Yes,
But
sir.
first you need, see, it's see, be specific with the statement. It is asking for number of tosses. If you
Yes, sir.
want
Y is
head and all
defined for
anything,
first
right,
head
you
come.
need first toss at least, right?
Yes,
See,
sir.
for getting the first head, that is what it's saying. It's saying H, TH, TTS, right? This is the meaning,
Yes, sir.
correct? So you need at least first toss, right, to get the first head, then second toss, something like this. Okay, for this case, you need 2 toss, right? For this case, you need 3 tosses, right?
3 toss. Yes, sir.
Okay, clear?
Clear.
Yes, sir.
Yes. Okay,
Sir.
so this is, yeah.
Sir, I have not understood this, sir.
Okay, what is your y? It says y define number of tosses required, right?
Yes.
Until the first head comes. So, okay, what will sample space to get the first head? It can be H, TH, TTH, right? To get
Yes.
this, you need to toss at least once, right?
Yes.
Okay. Okay. Can you say, if you see, if you take, can you say you are not tossing a coin and you are getting head?
No,
That's
sir.
not possible,
No,
right?
sir.
Okay. You need, see, it's a number of tosses. Okay.
Yes, sir.
Oh, okay, sir. Okay, sir.
Okay. Yeah. So let's move to the question number 2. So I think this discrete and continuous we have discussed lots of time in till
Discrete.
before.
Option B.
Option B. Okay. And
Sir, I have a question for discrete. Can I please ask?
okay, what is that?
Sir, in one of the lectures,
Hmm.
Pusha ma'am discussed like the apartment thing, right?
Option B and D.
I can't remember, but
Sir,
we
A
can.
and D.
So basically, she
Yes,
gave
sir. A and D.
Yes, sir, A and D.
Okay, I'm getting vote for option number A. Yeah, please go ahead. Yeah.
Basically, she gave a list of apartments with like floor area and everything. So she described the floor area as continuous variable.
Okay. Okay.
But because like it was a given set, right? Like there were, let's say there were 10 given areas, right? There were like
Uh,
10 distinct areas. It was not, can't
No,
we
no.
just,
Okay. Before going to that, can you tell me what did you understand by discrete or continuous? What's your thought? I will tell you where you are lacking. Just tell
no,
me.
so basically what's
So
happening is there is
discrete is
one
measurable.
one
Yeah, one second, one
question.
second. Let him speak. Yeah, please.
So there is one question in which, let me just post the question. Just give me a second. Sorry.
Okay. Before that, just tell me what do you understand by discrete and continuous? What's your thought?
So that thing I know, but like the concept is it's contradicting with one question, because there is one question.
Okay.
It's AQ
Where is
9, AQ 9.3.
okay? You are asking AQ 9.3.
Yes, sir. Um,
Okay. In which question?
it's question number 4.
Okay. What is your doubt?
So, so question number 4, sir. Here,
Hmm.
can't we say this is because the answer is discrete, but can't we say this is also continuous?
Why?
Because it is taking like points, like
No,
value.
no. Okay. That's why I ask you. Tell me the what did you understood by discrete continuous? See, don't understand like this. If discrete means it's always integer. First of all, okay. Discrete doesn't mean always integer. Okay. People got mistake. They will simply say check 3.2. It's a continuous. Don't go with the value. Try to understand the concept first of all. Okay. What discrete says? Discrete says it will take the first of all it's a countable. I can count. Okay, and it will take, what do you mean by count? It will take distinct values on real line. Okay, now
Yes,
if you, I will move to the continuous. So continuous, it we cannot count. Okay, and only one thing, it's a measurable. Measurement is there. I can measure, I cannot count the continuous random variable. Okay, now for example, for discrete, let's say I'm saying, and it can take any value between a given interval. Okay. So in case of discrete, let's say I'm saying number of people in a room, or in a, let's say in a today's class, let's say 34 people are there. So it's considered counting. I can count, right? Okay. Can you take any value and I can plot as a distinct on a real number line? Yes or no?
yes, sir.
Okay. Now in the case of continuous, it suppose there is two value. Let's say it is 10, this is 20, right? In case of continuous, it can take any value between these two. Okay, but in case of discrete, it's not possible. It cannot take any value between these two. Okay, first of all, only one difference you have to take care. You can't count. Countable is not there in case of continuous. Countable is there in case of discrete. Now, and it will take distinct value if it is discrete. If you come to this case, right? A random variable as is defined as the length of hypotenuse of the right angle triangle, which other two sides are determined by roll of two six-sided die, right? Now, to get the hypotenuse of the right side angle, what is the formula?
Uh, uh, like p square plus base square under root.
Yeah, it's something like this, right? It's just and it's a height, right?
Yes, sir.
Okay. For each value of these two, you will get a distinct value, right?
Yes, sir.
Yes or no?
Yes, sir.
I you can plot on a real number. It will take distinct value, or it can take any value,
So distinct.
right? So that's why it's a discrete.
So
Sir,
basically, like the confusion is because in the lecture, like
Mm-hmm.
we
Okay.
were,
Yeah. Go ahead. Yeah.
because we were given, like let's say in that example, we were given 10 areas, right? So we were
Mm-hmm.
given a particular set of,
Okay, so basically that area basically is not about particular set. It's okay. So area of a room or something. First of all, tell me, you will count or you will measure in something centimeter square or something. What?
that thing, like the area thing, I get it, like that's
Huh.
continuous. But
Hmm.
for like I'm saying for this hypotenuse one, like this
Mhm.
should also be continuous. That's what I'm saying.
See, divided the length of the right angle triangle. Basically, it's here it's not okay. Length is measure. It's not measurement, right? Yeah.
Yes, sir. So, but if it was like, let's say, like mentioned in centimeters or something, then it will be
Then
continuous.
it's the count. Basically, suppose I'm saying length of a, let's say, a room, or length of some, there is table. Okay. Suppose I'm saying there is a rectangle table, something like that. Okay. And let's say length is something, some centimeter, breadth is something centimeter. Then what is the area? Correct? Are you
Yes.
getting my point?
Yes, sir.
Okay. Okay, I think this should be some clearly mentioned. Okay, this should not be in centimeter, something like that. Okay? Yeah, so we'll correct it. Okay? I think there is that confusion is there.
Yes, sir.
Okay, I will correct it. Okay, so you understood the point here, right?
Yes, sir.
Discrete and continuous. Okay.
I'm just being particular, I think.
Oh, okay. Now the same thing you can see here. For here, in case, so A and D are correct. Who told me A and D? So if you see A, what is machine measure length of synthetic fabrics and associated imperfection in the fabric. X is what? Error in the measurement of the length, right? So it's X is what? Error in the measurement of the length, right? So here, what we are doing, we are measuring the length, right? Yes or no? Can
Yes,
you?
sir.
We can't count, right? And what is the y? Y is the number of imperfections per 10 meters. So it is counting, right? You are counting the how many imperfection is there. It can be one, it can be two, it can be zero, something like that, right? Basically, countable is there, right?
Yes, sir.
Yes,
So x is the continuous, y is the discrete. Okay.
very well.
Okay. Just see these
Sir,
options. Yes.
I have one question.
Yeah.
The stock market prices of any product, then
Hmm.
that is the discrete or continuous?
Okay. You tell me. What's your thought? It's a
I
continuous
think
or
it's a discrete
why?
because we are means we are counting, we are not measuring
Okay,
them.
stock price is something which can vary as per the time, right? It's not like you have some fixed number of coins in your pocket.
Okay.
Okay. So thing is that I told you, right? You have to be little bit careful whether it can take any value between these two or not. These two
Okay.
value, right? If it's taking only distinct value, right? Let's say I'm saying in a pocket, in your pocket, there are some 5 coins, 1 rupee coin, 2 rupee coin, 5 rupee coin, and some 50 paise, right? You know, initially we had some 50 paise coin and or something like that. Okay, some something like that you have, and
Yes.
10 rupee coin. Then it can take distinct values on real number line, right?
Yes.
Okay, but stock price can take distinct. Tell me,
It
stock price.
means it has a stock price will be in points also means. But
Don't worry about point. Don't worry about.
yeah.
Okay. For it, just suppose I ask you, give me 1.5 rupees. Then it's in point, right? So
Yes.
don't go with the. See, don't think point means always continuous. Point can be discrete also. Main thing is, okay, suppose the case is something like that. Suppose this is the 1 and this is the 1.5, this is the 2, this is 2.5, and it cannot take any value between these two, right? This is
Hmm.
only distinct points on real number line. It will be discrete. Discrete simply means you are able to count and it will take distinct value, right? This distinct
Distinct.
means it cannot take any value between the 2 points. Got it?
Okay.
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 Yeah.
So in case of continuous, that example you gave like 10 and 20 between those values, so it will take 10 and 20 also, or will it
Yeah,
not?
yeah, I think, yeah. See, in case of continuous, basically equality that doesn't matter. If you move to the very continuous, right? Very continuous, I mean, if you move the continuous, so probability, basically probability for a single point is going to be 0. So that's why in case of continuous, equality not matter. We are approximating the things. Okay. We are not, okay. In case of discrete, we are doing the things exactly. Okay. In case of continuous, what I mean, exactly and approximating. Suppose I'm saying, all of you know the binomial distribution, right? Suppose I'm saying x is follow binomial. Let's say 5 comma half. Okay, everyone is aware about this binomial, right? Then suppose I ask, tell me the probability x less or equal to 3. Then you can simply tell, you will calculate 5c3 half raised power 3, then plus, I mean basically 5c1 half raised power 4, it's 4, no, it's 5. Then 5c2 half raised power 5, I mean why it's 5, basically it will be half into half raised power 4, so I have written that. Then 5c3 half raised power 5, right? You will calculate and you will tell me the exact probability, right? Yes or no?
Yes, sir.
Suppose I'm saying x is following binomial, let's say 1000 half. Then tell me, suppose I ask, tell me the probability x less or equal to 998. Now tell me. Okay, will you prefer exact probability or will you prefer the approximate this probability?
Absolute.
Approximate.
Right? It's a very
Approximate.
tedious task, right? So continuous comes then. So these kind of things will. Why I'm just giving the rough idea, but these kind of things we will discuss in the stage 2 in depth. Basically, whenever we have large samples, right? You can't. I mean, it's very tedious task to do the exactly, right? So it will be very tedious task, right? Doing 1000 C1 half is power 1000, then something, right? So it's good to approximate. Approximate means we are moving to the continuous part. I mean, basically, if you see, in case of discrete, our CDF looks like something like this. Okay, yes or no? Suppose you have 5 data. Okay, then your
Steps.
CDF will looks like this. Yes or no? If you
Yes.
will be having some 1000, then your CDF will be like this, right? Very close, very close, right? Yes or no? For 1000 data set, something like that, right? So basically, it will be at the end you will get the some continuous curve. Okay, that is something we are moving to the discrete to continuous. Don't get don't take tension. Like this is not something is going to come, but I am just giving you some rough idea how we are moving discrete to continuous. Okay, so my point was, so okay, in this case, if suppose you have discrete case like this, okay, then suppose I ask, suppose this is the point A. I ask probability x equal to A. You can easily tell me difference between these 2 points, right? Okay.
Yes.
Suppose you have a curve like this, some continuous curve, and I ask this is the A. What is the probability x equal to A? Can you tell me? You can't tell me, right? Because it's not there is not any jump, right? There is no jump, right? So we can't calculate probability at a single point in case of continuous. It's a 0 in case of continuous. Okay. Are you getting right? Everyone is getting this rough idea. Okay. So let's move to the basic concept. Don't worry the things which you have discussed right now. These are all things we will discuss in this chat. So just be clear with some basic idea, right? Discrete is something we can count. Continuous something we can't count, we have to measure. Okay. So tell me by, I mean, in these options, which will be the discrete random variables?
B and D, sir.
B and T. Okay. Length of a phone call, it's not a discrete, right? Because we cannot count. Length will be, let's say, 1 minute, 2 minutes. It can be 1.32, something right there. 1 minute,
Yes.
let's say 1 minute, some second, right? Some nanoseconds, something like that. Amount of milk, something you have to measure in liter, right? We cannot count. So travel time is also you have to measure, right? In hour, in minutes, something like that. Okay. So if you see number of customers is visiting every hour in the shop, I can count. I can easily count. It will take some distinct value. Let's say it will take zero customer, one customer, two customers. There cannot be something 1.75 customer, right? Yes or no? Similarly, number of accident taking. So basically, B and D are the correct. Okay. So this is clear. Some rough idea. Okay.
Yes, sir.
So
Yeah.
explain option C. Option E. Option.
Okay, option E, suppose I'm saying travel time from your, let's say, home to school. Okay. Can you count travel time?
No, sir.
You can't count, right? You have to measure in minutes. Suppose your, uh, okay, Monday you
As
took
a
some, let's
phone
say,
call
10 minutes.
case.
Sorry?
As a phone call case.
Yes. Yeah. It's the same.
Okay.
So basically, let's say Tuesday you took some 11 minutes, something like that. So basically, you have to measure in minutes. You cannot count. Okay,
Okay,
so
I got it.
so question number 6 is this PMF. Okay, before this, any one of you can tell me what do you mean by the PMF?
So it's basically all the probabilities for the random variables.
Probabilities for random variable what? Yeah, it's a correct. Anybody else? Yeah, it's correct. No, you are right. Basically, we are okay. Full form is nothing but probability mass.
Mass function.
This is the full form. Okay, why? What's the meaning of PMF basically? So it's nothing but I'm using one terminology. It's a probabilistic behavior. Okay, for each values of x. X means for each values of the random variable. What do you mean by probabilistic behavior? Suppose I'm saying my random variable x is taking some value x1, x2 up to xn. Okay. So probabilistic behavior for this random variable. So what is the probabilistic behavior for this value? Okay. Meaning, in layman term, what is the weightage for this value? Right? Let's say P1. What is the weightage when a random variable will take this x2? This is P2. What is the weightage when random variable will take value xn? Let's say Pn. Okay. So let's say in this case, if you move to the this part, okay, let's me take that coin toss example. So we toss the coin 2 times, right? Right? And suppose I'm defining my x as a number of heads, right? And suppose this coin is fair coin. Okay. So if you see number of heads, so what will be? It can take 0, it can take 1, it can take 2, right? This is the
Yes, sir.
sample space, right? TT, TH, HT, and TT, right? So these are the possible cases, right? Now, tell me what is the probabilistic behavior, or what will be the weightage when x will take value 0?
1/4.
X will take value 0 means this case, right? And for this, what is the weightage? Basically, there is only one case. This is 1/4, right? And what will be weight when x will take value 1?
2/4.
There is two case, right? This
Half.
one and this one case, right? So
2
that
by
means
4.
1/4 plus 1/4, right? And what is the weightage in this case?
1/4.
1/4.
Okay, so there is two properties. If you see, this is the probability, and we know probability should be greater or equal to 0. Basically, it should be let's say 0, and from 0 to 1, right? It can't exceed 1 probability, and sum of all the probability will be 1. Okay, so basically these two are main properties of being a valid PM. Okay. Okay. I means valid PMF. If suppose in case any probability is not satisfying this case, or sum of all the probability is not equal to 1, then this is not a valid PMF. To being a valid PMF, these two properties should be satisfied. Okay. This rough idea is okay.
Yes,
Yes.
sir.
Okay.
Yes, sir.
Everyone have a rough and paper, pen and paper.
Yes, sir.
Yes.
So just solve it. I will give you 2 minutes and let me know what will be the answer. I got one vote for option number C. Aryan is saying option number C.
Sir, C.
Okay, I got one
Sir,
more.
C also.
C. Okay. Okay, so see, okay, let's go. Okay, so if you see what is it, it's clearly saying it's a PMF, right? So that means, and what is the question? We have to find the probability x equal to 5, right? So what is the probability at x equal to 5? It's nothing but 3t by 2, right? So it's not exact value here. So first of all, we have to find here t. You can see is the unknown value. So to find the value, this value of t, so I can use the property of PMF. Right? And what is the property of PMF? All the probabilities should be greater than 0, and the sum of all the probabilities should be equal to 1. So that means sum of all the probability should be equal to 1. That means here if you see 0 plus t by 2 plus 4t square plus 3t by 2 should be equal to 1, right?
Yes, yes, sir.
Now, if you see, so this 3t by 2, t by 2, it will make it's 4t by 2 plus 4t square equal to 1, right? So here it will be 4t square plus it will be 2t and plus t, 3t equal to 1, right? So that is 4t square plus 3t minus 1 equal to 0. Yes or no? Oh,
Yes,
yeah,
sir.
option number C is
Yes,
the
sir.
correct. So that means from where it will be 40 square, I can do like this or not, right? So here it will be 40, I can take common, it will be t plus 1, then minus 1 I can take common, it will be t plus 1. So t plus 1, 40 minus 1 equal to 0. Now either this will be equal to 0 or this will be. So here I will get t as minus 1 or t as 1 by 4. Basically it's 40. Let me do here. Basically, it will
Yes,
be
option C is correct.
40 equal to 1. This is t is equal to 1 by 4. Now tell me which value I will prefer 40.
1 upon 4.
1
By
upon 4.
4.
Why not minus 1?
Because
So
probability
probably
Correct.
property not.
So if I will use minus 1, then probability will be less than 0. Okay. So t
Yes,
will
sir.
be 1 by 4. So t will be 1 by 4. If you put value of t here, so probability x equal to 5 will be 3 by 2 into 1 by 4, which is nothing but 3 by 8. Okay. So 3 by 8 is the correct answer. Okay. Is this clear?
yes, sir.
Yes, sir, clear.
Fine.
Yes, sir.
Okay. So next, okay, so this is given to. Let me ask you what do you understand with the CDF part? Next question is related to CDF. First of all, what is the full form of CDF? This is the cumulative distribution
Function.
function, right?
Frequency.
So what do you mean by cumulative distribution function? Yeah, tell me. Anyone? Okay. Yeah, please, if you know, if you are willing to say something,
Sir,
please feel free to say. Yeah.
sir, can
You
you
have to
please
mute,
move
sir.
to the previous question?
One. Yeah. What is doubt in this question? In this question, you have doubt? Yes, no. Okay, so tell me what do you mean by cumulative distribution? By the name or something, any idea? I'm audible, right?
Yes, sir.
Okay, so let me start it. So what we have done in the PMF case? What's the in case of PMF? We have random variable and it will take some value, right? Correct? And there will be some probabilities associated with each value. Correct? Yes or no? Now, suppose I asked probability x equal to x2, you can simply tell me by this table it's a P2, right? I ask probability x equal to x4, you can simply tell me P4, something like that, right? So, whenever I'm interested to know the probability of a single point, when x will take any value, let's say what is probability x will take x2, x3, something like that, I can use the PMF. What about, suppose I ask probability x less or equal to x3. So in this case, what we have to do basically, I have to consider all the case till x3, right?
Yes, sir. Yes, sir.
So what we are doing here, we are accumulating, right?
All the probabilities.
Okay, we are accumulating all the probabilities, right?
Yes, sir.
Till x3, right?
Yes, sir.
So that's why that name called CDF, means cumulative distribution function. So cumulative is nothing but came from the, we are accumulating, suppose we are interested in the probabilities till a particular point, right? Till a point, not at a particular, okay? So probability, suppose I ask probability x less or equal to x4. So here we see, we are interested till x4, not at a single x4. Yes or no?
Yes, sir.
Right? So this is something called CDF. So property is same. I mean, it will take CDF will take value between 0 and 1. It can't take value beyond 0 and 1. Okay, as this is also a probability density. I mean, it's a probability also, right? Okay.
Okay, sir.
Okay. So in this case, what we got 1, 2, 3, 4, 5, right? Okay. So let me write down 1, 2, 3, 4, 5. Just tell me the values. So it's 1, 2, 3, 4, 5, and values will be 0, 1 by 4, right? Then 1 by 8, right? And then 40 square, that means 1 by 16. 4 into 1 by 16, that means again 1 by 4, 3 by 8, right? So summing up to 8, right? Oh, I mean 1. So it will be 2, 3, 5, 1, 6, 2, 8 by 8. Yeah. So this is your x and this is your p of x, right? Now, okay, so if I want to plot, okay, so what is the CDF basically? CDF says it's nothing but, okay, we are denoting with capital Fx of x. Okay, so that means x, capital X, probability x less or equal to x. So this x is nothing but one particular value of your random variable. This is your random variable, capital X, and this is one particular value. In simple notation, you can say Fx of A is nothing but probability x less or equal to A. Okay, means we have to accumulate or we have to consider all the probabilities till point A. Okay. Now, how we are denoting the CDF basically? So here, suppose I ask what is the probability x less than 0? What will the probability? Tell me.
0.
0.
Because, okay, okay, no, not 0, 1. Because possible ranges are 1, right? Before 1, what is the probability? Nothing.
0.
Right? 0. Right?
Yes, sir.
If I will move 1 to 2, then
1 by 4.
1 by 4.
no, just see carefully.
By 4.
1 upon
1
4
That will be 0 again.
is again 0, right?
0.
plus 1 by 4.
Yes, sir.
So this means what? This means what? We are considering the probability at 1, right?
Yes,
1
sir.
but less than 2.
Yeah.
Oh, okay, sir.
Okay. What about this case?
1 by
1
4.
upon
4
1 by 4.
Now 1 by 4.
less than
1
2.
by 4. 1 by
And this, okay, can you tell me this 1 by 4, how did you get?
1
X
by 4
equal
plus
to
0.
Sir,
2
adding
less
0
than
and 1
equal
by
to
4.
2.
See,
Yes.
in this case, yeah, that is the correct answer. So in this case, what we are doing, we are interested in probability till 2, right?
Yes, sir.
Till 2 means we are going to add this plus this,
This.
right?
Right.
Okay.
Okay.
What about suppose I am saying this case, that means here we are interested in probability till 3, right?
3
So
by
that
8.
means
4 plus 1 by 8.
it's
3
not
by
1 by 8.
3 by
It's 0 plus 1 by 4 plus 1 by 8. That is 3 by 8.
3 by 8.
Okay. What about
Okay.
4 before 5? So
5 by
it
8.
will be 3 by 8 plus this 1 by 4,
1
right?
by 4.
It's nothing but
5 by
5 by
5 by
8.
8. Correct. And if you see 5, I mean greater or equal to 5, there is no any value after
1.
5, right? So it's a 1, right? How did you
1.
get
Yes,
this
sir.
one? This is 5 by 8 plus the last 3
So
by 8.
total.
I will get the 1. Okay, this is something I can define the CDF, right? And how
Yes,
this will
sir.
look like, suppose this is my x and this is, let's say, capital fx of x, right? Okay, so suppose this is the 0, this is the 1, 2, 3, 4, 5. So before, okay, before 1, it is taking value 0, right? Okay. Yes or no? From 1 to 2, if you see, I mean, before 1, it is taking value 0. Correct? From 1 to 2, it is taking value again 0. Right? That means what? This is something like this.
Yes, sir.
Right?
Yes, sir.
From 1 to 2. Right? And from 2 to 3, it's a 1 by 4. Okay. So suppose this is 0 and this is 1 by 4. Scaling we have to adjust. Okay. Let's say this is 2 by 4. This 3 by 4 and something. This is a 4 by 4. Okay. Something like that. Okay. From 2 to 3, what is this? 1 by 4, right?
Sir, I am not getting
Yes,
this
sir.
graph. Please, can you repeat again?
Okay. I will come to that. Okay. So this is CDF graph. What we are doing, if you see before 1, less than 1, that means what? It's a 0, right? So less than 1, it will take value 0, right? 0
Yes.
means, okay. And
Sir.
from 1 to 2, what is the value? It's again 0. 0 means this x-axis, right? So 1 to 2, right? If you see why am this bold circle is equality, okay. Open circle is there is not equality. I mean there is jump for to the next point, okay. Similarly, if you see 2 to 3, 1 by 4 is taking, right? So 2 to 3, 2 is equality sign and 3 is
Yes.
not including.
Sir.
So from 3 to 4, this is 3 by 8. 3 by 8 will be how much? I mean, it will be
Less
around
than 1 by
0.375, right? Before this 1 by 2, right? So I'm just assuming it's somewhat here, okay? So 3 to 4. So far, so good?
Yes, sir.
Correct? Just
Correct.
assume this is your 3 by 8, okay? Okay. So
Yes,
now,
sir.
then 4 to 5 is 5 by 8. So 5 by 8 is, I mean, it's more than 1.2. So I'm assuming here itself, okay? I mean, we have to arrange, we have to do the proper scaling, but I'm just doing some, I'm just, I want to give you some rough idea here itself, okay? So this is like from 4 to 5, right? Then after 5, it is taking value 1. Okay, suppose this is the 1. 4 by 4 means it's 1. So from 5, it will take value 1. This is so far so good.
Yes, sir.
Now, so basically probability, suppose this is the cumulative probability. Suppose I ask the probability at a single point, let's say probability x equal to 4. That means what? This probability nothing but this jump. Okay, how much jump is there, right? So how much jump is there? So what is this? This is 3 by
3
8.
by 8 minus 5 by 8.
Not 3 by 8. This is basically 5 by 8. So 5 by 8 minus
3
this
by 8.
one, 3 by 8, right? So it will be 2 by 8. That is 1 by 4. So if you see probability at x equal to 4 is what? 1 by 4. Right?
Yes, sir.
Okay. Suppose I ask what is the probability at x equal to 2. That means this jump, right? So this jump is what? Tell me.
1 by 4 minus 0.
1 by 4 minus 0, which is nothing but
1 by
if you
4.
say probability x equal to 2 is again 1 by 4, right? Okay. Is this clear?
Yes, sir.
Yes, sir.
So this is something we can plot the CDF of a
Sir,
discrete.
can you please explain
Sir.
why in the 3 greater than x greater less than 4 case we consider x equals to 1 and x equals to 2?
Where?
Sir, the third case, 3 greater than equal x less than 4. Yes, sir.
Okay,
Sir,
what do you
why?
mean by what do you mean by this case? Tell me. What do you understand by how much which value x will take?
Which is x equals to 3
X equal to 3.
plus
No,
less
what
than
do you
4
mean by
and
this?
x
Means
equals to
x
3.
can take value till 3, right?
Yes, sir. Yes.
Right?
Yes, sir.
So,
Yes.
so that means till 3 means we have to add all these probabilities. So this is similarly before 4 I'm talking about. Okay?
Oh, okay.
Okay. Yeah. So
Yes.
next question is related to CDF itself. Okay. So I mean I gave you the idea. Just see the question. Cumulative distribution function of the number of defective items in the shipment of every 10 items is given as like this. So you have to find out the value of probability that there are 3 defective items in the shipment of 10 items. So this kind of question you can expect during the examination. So okay, what do you mean by probability that there are 3 defective items?
X is equal to 3.
Less than 3.
Less than 3.
No, read the question carefully. There are 3 defective items.
Exactly 3 items.
Correct. I'm interested. What is the probability of x equal to 3? How will you find probability x equal to 3?
X equal to 3.
How will you
Then
find from the CDF? I asking. That is my question.
one
0
So we can
minus 1
means
minus 0.91.
1 minus 0.9.
0.91.
it will
So
be
basically
1
this
only.
minus this case, right?
Yes.
So
1 minus 0.91, which is nothing but 0.
0.09.
Okay, that is the case. Okay. Suppose in this question, I will give you some twist. Let's say I ask what is the probability x less than 3 given that x is greater or equal to 0. Tell me. I don't
Why
want.
did you subtract this from this?
Okay, what we have done just a few minutes before, please tell me.
0.9.
If you want probability as a single point, right? Singleton point, right? So this is the jump. You have to subtract from upper to lower one.
Yes, sir. Sorry. Thank you, sir.
Got it? Okay. So if you see here, for x equal to 4, what we have done? We have subtracted the probability from upper to lower one, right?
Yes,
Suppose
sir.
no problem, no problem. See, it happens. See, concept should be clear. That's our main concern. Suppose I ask probability x equal to 5, then how will you do? This upper 5 is this jump, right? And this upper is what? 1. So 1 minus 5 by 8. Yes or no?
Yes,
This is nothing but
Yes,
3 by
sir.
8.
yes.
So at 5, we see 3 by 8 is there, right? So same, it asking about till 3. So basically, your graph will be something like that. Suppose this is 1, so it will be for 3. It is taking value from 1 onwards, right? Okay. For this case, tell me the just formula. I'm not interested in the answer. Just tell me what will be the formula.
Sir, I didn't get this case. Can you please explain it?
Probability x less than 3 and
Which
x
case you did not get?
greater than equal to 0 divided by
Simply
probability.
asking what is the probability that x will be
Conditional
2.
probability.
1 second, Madhu. Yeah, someone is
1
asking the
and 2.
probability. Someone is asking this case. Yeah, what is your doubt?
No, sir, I'm not asking this case. You have written this x less than 3. I'm asking this. Can you please explain it?
Yeah, I have not done it. I'm asking with you guys. I want formula. I don't want the answer. Just tell me how will you proceed?
X less than 3
Conditional
and x
probability.
Okay, first of all, this is conditional probability. Probability A given B.
Yes,
Yes.
sir.
So it will be probability of A intersection B divided by probability of B, right?
Yes,
So
sir.
it will be probability x less than 3 and x greater or equal to 1 divided by probability x greater or equal to 1, right? How will you
Yes.
proceed in such kind of questions? That's my concern. So if you see, what is the common for this case? Okay, x less than 3 means it will take value 0, 1 and 2
Yes, sir.
for this case, right? And x greater or equal to 1 means it will take value 1, 2, 3, right? What is the common in these two?
1, 2.
1,
1 and
2.
2.
1, 2.
1 and 2, that means you have to find the probability at x equal to 1,
1
Plus.
and plus x equal to 2.
correct? I mean, basically, you have to consider the probability x equal to 1 plus probability x equal to 2, right?
Yes.
And the
Yes.
denominator part, x less or equal to 1, that is probability at x equal to 0 plus probability x equal to.
Greater.
Yes, sir. It's greater.
Oh, sorry. Yeah, thanks.
So we
Okay, so
can
it's a
say
greater
1
or equal to,
minus.
or I can simply say 1 minus probability at x equal to, I mean, x less than 1, right?
Yes, sir.
Yes.
X less than 1 means, so what will be the probability now? Probability at x equal to 1, how will you compute? Tell me. What will the probability at x?
0.78
So 0.78 minus 0.41, how much this will be?
0.37.
0.37. For probability x equal to 2, I have to subtract this to this, right?
0.13.
Point
No, sir. 0.909.
0.09. If you subtract 0.9128, how much it will be? 0.13, right?
0.13, yes.
And what is 1 minus probability x is less than 1? That means there is only one value less than 1, which is x equal to 0. So above part will be 0.5, right? And divide by 1 minus probability. What is x equal to 0? Tell me.
0.4.
0.41.
0.41, right?
1. Yes,
So
sir.
it's nothing but how much? It's coming out to be,
0.59.
yeah, 0.50 divided by 0.59. This will be the answer. I mean, after calculating, we will get the answer. Okay? Some rough idea is clear. I mean, how we
Yes,
can
sir.
find the values, probabilities from the given CDF, right? Okay.
Sir,
So one important hint you can say, this is something important kind of question. You can expect this kind of questions, this level of questions in your interview. Okay.
sir, why
Yes,
we
they
need
put
to
0.37.
divide 1 minus p of x less than 1?
What is this? First of all, did you get this one? Probability x greater than or equal to 1, we have to do.
Yes.
Okay, so there are two things. If probability x greater than or equal to 1, so I can write this as same as 1 minus probability x less than 1.
Yes, yes,
The
yes.
same thing I have done, right?
But my question is why means you are asking p of x less than 3 or x greater than 1, right? So
What is
we
okay? What is the meaning of this sign?
okay, given that.
Okay, this is the conditional probability,
Yeah,
right?
given that. Given.
Got it?
Got it, sir. Got it, sir.
Yeah. Okay, so far so good.
0.37. Small doubt.
Yeah, 0.37. Yeah.
Yeah, this value 0.37.
What is this?
P0 x is equal to 1.
Okay, how will you compute probability x equal to 1 from the given CDF? Tell me.
0 plus 1, na? Point.
No, it's already CDF, right?
Correct.
So you already added the value. So to get the probability at a particular point, you have to subtract or you will add.
Subtract, sir. Okay.
Got it? Because in
Subtract.
CDF,
Correct.
okay, in CDF, what we are doing, basically, if you see, we are basically accumulating the probabilities, right? We are adding the probabilities, correct? But to
Okay.
know, to get the probability at a particular point, so we have to basically we have to find this jump. This jump is nothing but we are subtracting the probabilities, correct?
Okay.
Got it?
Understand.
Oh, yeah, fine, great. Okay. So far so good, everyone.
Sir. Yes, sir.
Okay, fine. So this is the one question. Just do it. Okay. I will give you 2 minutes and I will be back in 2 minutes. Okay. Just do this question.
Sir, will you share this PDF on dashboard or we should take screenshot? Excuse me, sir. Wait a chat.
Yeah, hello. Yeah, what is the answer?
Sir, 19.
21, sir.
90?
19, yes, sir.
21.
19, sir. 19.
Okay, so someone is saying 21. Okay, we'll see both. No problem. Okay, we'll see which one is the correct one. Okay, before that, can you tell me what is the expectation? What's the need of that? Anyone?
So it gives the average value. Um,
Okay, fine.
Sir, for a long run, it gives the average value.
Basically, expectation is something we are saying. Long run average means what we can expect if I'm going to do any experiment for a long number of times. Okay, so I will give you one rough idea. What's the need? Okay, suppose you have given the PMF. Okay, and I'm saying x is x1, x2, x is taking these all values, and probability is associated with each value is nothing but, let's say, p1, p2 up to pn. Okay. So what this is, what PMF provides here? Basically, if you see, this PMF provides us the information about my random variable, right? What kind of distribution is this, right? Suppose I want, I'm saying just give me the information about random variable, then you can simply say x is taking these all possible values, and probabilities are associated with this value is this, with value x2 is this, value xn is this, something like that, correct? Yes or no? This is something PMF provides us.
Yes, sir.
Correct? Now, suppose suppose I ask you, give me the information in a single number, then how will you do? Give me information for my random variable in a single number. How will you do? Suppose I'm interested, right? Then you can't simply say probability x equal to taking x2 is p2, right? That's not a correct information, right? Or
So C lambda I, that formula.
You can't simply say x equal to x3 simply p3, something like that, right? Suppose I'm asking, explain your random variable in a single number. Are you getting my point? What I'm trying to say?
Yes, sir.
Okay, suppose I want to explain my random variable, I want to give information about my random variable single number. So for that, this expectation came into the picture. Okay. So what is this? Okay. Okay. What PMF provides you? PMF provides me the information about my random variable, right? What are the possible values my random variable x can take? What are the
Correct.
probabilities associated with each values, right?
Yes.
Then what's the need of expectation? Suppose rather than explaining these kind of things, all the values, all the probability associated with these values and all, I ask, explain your random variable in a single number. Then how will you explain? Right? That's something interesting question. Yes or no? So to explain your random variable in a single number, this expectation came into the picture. Okay. Okay, for example, that same thing you had done week 4 and all, week 3 and all. Suppose I'm saying there is university A. In that university, 5 students got this kind of packages. Let's say in 10 lakhs. 10 lakhs with suppose this is 20 lakh. This is 10 lakh, 20 lakh, 30 lakh, 40 lakh, 50 lakh. Okay. Now what will be the A? Okay, suppose. Okay, I ask what is the just explain this number in a single number. Then what you prefer? You will simply tell me average annual package. And suppose I ask with you, tell me give me information about annual package of college A, university A in a single number. You can't simply say 10 lakh, 20 lakh, right? You will simply say on an average, there is a 50 lakh, or no, not 50, it will be 30 lakh, right? Yes or
Yes,
no?
sir.
You will say, right? Annual average package in college, this is 30 lakh. Then I will be having some idea in a single number for the annual packages of college, correct or no?
Yes, sir.
Discrete
So
value.
this, yeah. So this is something this expectation come into the picture while explaining. I mean to explain to give the information about your random variable in a single number. So this expectation is nothing but I can compute simply value into what is the probability associated with this value. Okay, plus simply x2 into what is the probability associated with this value, plus so on, simply xn into probability associated with this value. Okay, basically it's kind of weighted average, right? Okay, so expectation of x will be simply x1 p1. I'm writing in short, basically xn pn. So this is something we are discussing in case of discrete. Okay, so here it will be summation I is equal to 1 to n xi into probability at x equal to xi. So this is something expected value of x is defined for a discrete random variable. Okay. Now rough idea is clear about expectation. Yes or
Yes,
no?
sir.
Okay.
Yes, sir.
No,
Yes,
so,
sir.
so this question was related to the expectation of uniform distribution. There are two kind of uniform distribution. There is one discrete uniform distribution. Okay. Another one is the continuous uniform distribution. Okay. So we are not going to study in this week continuous. This continuous uniform distribution has been covered in week 12. Okay. So this is discrete uniform. So by the nomenclature, if you see uniform is uniformity is there, right? Okay, so this is something one of the example for uniform distribution means the x is taking value 1 to up to n. The probabilities are the same for each of the value, right? Okay. Any other example apart from this you can think?
Passing two dice.
And dice.
Sorry? Dice, yeah, dice one is a very good one. Like if you roll the die, what are the possible outcomes you will get? You will get 1, 2, 3, 4, 5, 6. And what is the probability associated with each value? It will be
1 by
1 by
6.
6.
1 by 6.
1 by 6. 1 by 6.
Basically, this is nothing but
Point.
equally likely events, right?
Correct.
Correct. So
Yes.
here, okay,
Yes.
so here 19 is okay. So we can move. Okay, what is the expectation of x? Nothing but summation of each xi into probability of xi, right? So what
Yes,
is
sir.
each xi? 1 into 1 by n plus 2 into 1 by
1
n
by n.
plus
3
3 into 1 by n up to n into n by 1 by n, right? So here 1 by n I can take common,
Yes.
right? It will be 1 plus
Yes,
2
sir.
plus so on up to n, right? And
Yes, sir.
this is what this is something sum of first and natural
N
number. So
factorial.
this will be
N.
n plus 1
N
by
plus 1 by 2.
there is one so n will get cancelled out. So expectation of x is nothing but n plus 1 by 2. So it is asking okay, what the information we have given? It given expectation is as a 10, right? So that means this n plus 1 divided by 2 is 10. So that means n plus 1 is will be 20 and n
N
will
is
be
equal to
20 minus 1 which is 19. Okay, someone told me 21. I think they have made a mistake. They have added this 20 and 1. Okay, so 19 is the correct answer. Okay, this
Okay.
is clear.
Yes, sir.
Okay, fine.
Yes,
Yeah.
sir.
Yes, sir.
Okay, let's move to the next question. I think this is something called properties of expectation, right?
Yes, sir.
Yes, sir.
Tell me which
Sir.
one is the true.
Sir, first one is true.
Okay,
Second one is also true, and
Second one.
Fourth.
last one.
last
Last
one.
one
Last one, yes,
also
sir.
true.
Third
Yes,
one
sir.
is not true. Why?
Sir,
Sir,
because
because they added.
They
Yeah,
added.
because okay.
They
So there
added,
is
sir.
properties. Okay, so let me clear some properties. What about expectation of a constant? A suppose is a constant. What is the expectation of a constant?
A.
Just give me.
Sir, a constant value, that constant value.
sir, constant value.
No, sir, that constant value.
Constant value multiplied by expectation.
Okay,
No,
so
it's
someone is
0.
telling 0. Okay, one second, no
0,
problem.
0.
Things will clarify. Why 0? Tell me.
Because it doesn't vary now, sir.
No, I'm not talking about variation here at all. I'm talking about expectation of A. I mean, A is a constant.
It should be A.
It will be A. How I will tell you. Suppose I'm saying X is a random variable, it is taking value A. Only one value A. What will be the probability? Tell me. What will be the probability? 1. And what is the expectation of X?
A
A
into 1.
into 1. Right?
Yeah.
So if now got it?
Yes,
Expectation
sir.
of any constant is nothing but that constant. Right?
Right.
Now, if what about expectation of A into X?
It's
Like
AX.
A
into
into
expectation
A.
of
X
X.
A
of X.
into expectation of X. You can
Expectation of X.
verify these things by this example. By this example, you can verify how. Suppose I'm talking about expectation of 2x. That means you have to add. It will be 2. It will be 4 up to 2n, right? Okay.
Yes, sir.
So if you will place this all value here, 2 plus 4 plus up to 2n, so you can simply see 2. I will take as a outside, right? At the end, it will be 2 into n plus 1 by 2. Correct. What is this now? This is nothing but 2 into expectation of x, right?
Yes, sir.
Okay. Now, what about expectation of ax plus b? That means, so
A
if you
into
have two things,
expectation of
so that means I can simply write expectation of ax plus expectation of b.
B.
And we know expectation of ax is nothing but a times expectation of x plus and expectation of a constant is nothing but that constant, right?
Yes, sir.
Okay.
Yes, sir.
Similarly, if you have to expand this formula itself, I mean, you have to just expand this. It will be a square x square plus b square plus 2abx, right? Now, if you apply expectation here, then it will be, see, a square is nothing but constant. I can take outside expectation of x square. Expectation of b square again is the constant. It will be b square plus 2ab expectation of x. Right? Similarly for this.
So
Okay.
what would happen if the whole thing was in square?
Whole thing was in square. I
Like,
mean, what do you mean by this case?
yes, sir.
Okay, so it will be expectation. Okay, I mean, you are talking about this thing basically. So it will be this case. That's all.
Okay, sir.
Got it?
Yes, sir.
Sir,
Yes.
is it given that it is, I mean, for all the options, those are PMF?
Yes. Basically, here we are talking about in case of general. Suppose I have some general random variable, right? Okay. So
Okay.
if expectation x is exist, basically there's this expectation of x should exist. So we are talking about here. If expect, I mean, we are assuming basically expectation of x is exist, then whether this which option will be true. Basically, we have to apply the properties.
Okay. Sir, but
If
if you,
there is something case where we are going to mention property and all, where suppose I'm writing, okay, suppose I have written here expectation of x is not exist, then accordingly you have to choose the option. Okay.
sir, how not exist?
Exist means, see, while we are doing, okay, this, okay, suppose you have x, some x1, let's say is taking some value, right? Let's say till I don't know the upper limit, same probability associated and don't know the upper limit. So exist means summation should converge. Okay.
Okay.
It should be less than infinity actually. Okay, I mean, there will not be any question in this first sem of the your stats on first level, first foundational level, whether not, I mean, expectation will not exist, so you can assume so far expectation is exist. Okay, exist means values, if you add all the x into px, x into px, it should be less than infinity. That is the meaning of existing. It should not be infinity. That is the, okay.
Okay, sir.
Fine. Okay.
Yes.
So similarly, suppose you had two random variables, then if I have two random variable x plus y, so it's the same as expectation of x plus expectation of y. So this is the property we can verify. So we are not going into the derivation part here. Suppose similarly I'm asking expectation of ax plus y, then I can simply write expectation of ax plus expectation of y. And what about this? I can simply write a times of expectation of x plus expectation of y. So basically here it doesn't matter whether these two x and y are independent or dependent. Okay, no matter very less. Okay, clear?
Yes,
Yes, sir.
Okay, so next question is related to variance. Can you tell me what's the use of variance before going to the question part? Just anyone, any thought? You can go ahead, no problem.
Sir, it
Sir,
is
it
just a
tells us
spread
Sir,
how much the
Yeah.
data is spread
Straightness of the random variable.
Okay. Basically, okay, what expectation tells us? It's give me some central idea, right? Right?
Yes, sir.
It is not telling me any information about variability. Okay, let
Yes,
me
sir.
take a university example itself. Okay, I will move to the various parts. Stop. I will take one example. Let's say there is one college A, another college B. Okay, so let's say annual package of 5 students are 1 lakh, 2 lakh, 3 lakh, 4 lakh, 5 lakh. In the university B, let's say some 3 lakhs, 3 lakhs. Okay. Okay. Suppose what is the average for this case? Let's say X bar
3.
3. What is this case?
3.
3.
Okay. Now you can simply come to me and you can simply like you can simply give me information like on an average annual packages are same in the both college. Is this okay? In reality, is the annual packages are same or there is variability?
Sir, variability.
Right? Variability is there, right?
Yes, sir. Yes,
Right?
sir.
So that's why
Yes, sir.
variance comes into the picture. Means we are observing how much variability is there from each observation from its mean, right? On an average. Okay. So in case of random variable, it's defined as variance of x is nothing but expectation of x minus mu square. So this mu is nothing but expected value of your x. Yes, yes, this mu. Do you any query? Vishnu has raised hand, right? Or it was by mistake? Okay, so basically this variance of x is defined as nothing but expectation of x minus mu. So this is nothing but deviation of each value from its mean. Okay, so okay, if you will expand this one, so let me expand for now. So this mu is nothing but expected value of x, right? So if you will expand, what you will get x square plus mu square minus 2x mu, right? If I will
Sir.
expand this
Yes, sir. Yes, sir.
now, if I will take expectation inside the bracket, that way it will be expectation of x square plus expectation of mu square minus 2 mu expectation of x,
Yes, sir. Yes,
right?
sir.
So it will be expectation of x square plus this is the constant, it will be mu square, right?
Yeah. Yes, sir.
Minus it will be 2 mu, and what is the expectation of x? Again mu, right? So expected value of x square plus mu square minus 2 mu square. So it will be expected value of x square minus mu square. And what is mu? Mu is nothing but expected value of x is nothing but expected value of x, right?
Whole square.
Okay. So this is something variance of x is defined. You can use this formula or you can use this formula. Both one is the correct. Okay. So basically we are preferring this one because we have expected value of x. Then how you can compute expected value of x square? Suppose x is something. Let's say 1, 2, 3, 4, 5, 6. Okay. Then probabilities are 1 by 6, 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 1 by 6. What will be the expected value of x? It will be 1 plus 2 plus 3 plus 4 plus 5 plus 6 whole 1 by 6, right?
Yes, sir.
Yes,
Yes,
sir.
sir.
Expected value of x square then it will be 1 square plus 2
2
square plus 3 square plus 4 square plus 5 square 6 square. Basically here it will be 1 into 1 by 6 into 1 by 6. So I can take outside exact at a time it will be 1, right? That is something you can simply find the variance with the expected value of x square, which whatever value will be there I don't, and expected value of x. Got it?
Yes,
Okay,
sir.
let's come to the some property. Then I will move to that. Okay, what about variance of a constant?
Sir, A square.
Zero. Zero.
0, sir.
Someone is saying a square. Why? I'm interested. Can you tell me the reason?
Sir, 0.
If you are saying something, right? So just be clear with, because and then being an statistician, right? You have to make the conclusion. You are going in real field, okay? So variance of a constant is 0. How I will tell you? What is the variance of x? Expected value of x minus mu whole square. variance of a constant a means that means expected value of a minus, and what is the expectation of a will be? Again, it will be a. Yes or no?
Yes,
Yes,
sir.
sir.
So it will be 0, right? So
Yes,
variance
sir.
of a constant is 0, right? Now what about variance of a times of x?
Is
A square
x.
A square x. How will you
variance
get?
of x.
Because variance of ax means expected value of, if you see this formula, instead of x I have ax, right? Minus, what is this mu? This mu nothing but expected of x. Then what is the expected of ax? It will be a times expected value of x, that means a times mu, right? This will be minus a times mu. Yes or no?
Yes, sir.
Yes. Okay, okay,
Yes,
forget
sir.
about this. Let's do like that. Okay, what is the variance formula? Variance of x is nothing but expected value of x square minus expected value of x whole square, right? Instead of x I have ax, that means expected value of it will be a square x square. Yes or no?
Yes, sir.
Yes, sir.
Minus expected value of ax whole square,
Whole
right?
square. Correct.
Now it will be a square, I can take, it will be outside. From here if you see, it will be a times expected value of x whole square, right?
Yes, sir.
It
Yes.
will be a square expected value of x square minus, here it will be a square if you take outside of the square bracket, right? It will
Expected
be now.
values. Whole square.
Now if you see, a square is the common. Okay. Now I got expected value of x square minus expected value of x whole square, right?
Mhm.
So variance of ax is nothing but what is this? Variance of x. So a square variance of x. Clear?
Clear, sir.
Okay. What about variance of a? Sorry, variance of minus a times x. Tell me.
It is same.
Variance.
A
Yes,
square
variance of
variance of
x.
x.
To minus a square variance of x, right? So it will be again same, a square variance of x, right? What about variance of x plus b?
It is
Is
same
equal to
as
variance of
variance of
x.
x.
Variance of x.
Variance of b.
It will not be effect. There will not be any effect of adding a
Constant.
A
constant, right?
constant.
Because if you
Yes.
add b, I will give you some rough idea here. So here what you will get, if you put here, so you will get x plus b whole square, right? Something. Or else you can do directly here. It will be x plus b minus mu minus b, right? B will get cancelled out, at the end you will get x minus b whole square, right?
Yes, sir.
Yes, sir.
Okay, what about variance of ax plus b,
Is a square
A
into
square
bx.
of variance of x.
right?
Yes, sir.
Yes, sir.
Now just tell me, suppose I have two random variables, let's say x and y, okay? Then what about this case? Tell me.
Sir, we cannot say anything until unless
No,
we know that it is.
I can say one thing.
Variance of x plus variance
plus
of
Variance
variance
of
of
Sir,
y.
if events
Yes.
are
I can this
independent.
thing. I can say this thing, sir.
Yes, sir. Yes.
Okay. So basically, this is something. If there is not any information about independency of your x and y, okay? So what happens if x and y are independent, right? Okay. So in case of independence, covariance between x and y will be 0.
Zero.
So it
Yes,
will
sir.
be 0. So to get the case variance of x plus y, this is same as variance
X
of x
plus Y.
plus variance of
Variance
y.
of y.
It will be true only when x and y are
Independent.
independent, right? Okay. You can't
Yeah.
say in general actually. Okay, so basically why this covariance is becoming 0? I mean covariance. Do you want the reason or should we move?
Some moves.
We can okay. Okay, no problem. We are moving, but these all things we will be studying in detail in this class. Yeah. I mean, there is because covariance defining something expected value of x into y minus expected value of x into expected value of y. And if x and y are independent, so basically x into y is nothing but expected value of x into expected value of y. If you will put the value here, expected value of x into expected value of minus this, so this will become 0. Okay, so that is something we will discuss. So that's not part of concern here. Okay. So, okay, tell me one more thing. I'm just curiosity, I'm asking. I'm saying X and Y are independent, then covariance 0. Okay. Suppose I'm saying covariance 0, then can I say X and Y are independent? Will it imply X and Y are independent? Then I'm saying covariance between these two is 0.
No, sir.
Can I say this one?
Not sure.
No, sir.
No, sir.
Why?
Because it also becomes 0.
It's not true always. Okay.
Yes,
Why? I
sir.
will tell you. Because covariance tells us the linear association between two variables. Okay. I mean,
Yes,
that's
sir.
the concern of V4, but I'm just giving you a rough idea. Concept should be clear. So covariance between X and Y 0, that means I'm saying there is no covariance, tell me linear association between two variables. If I'm saying covariance is 0, that means I'm saying no linear association is there. Okay. No linear association is there. That means it can be dependent like this. I can say Y is dependent. Y is, between X and Y relationship as Y equal to X square. And in this case also you can find covariance between X and comma Y 0. Got it? So this is not linearly related, but it's related. Okay?
Yes.
Yeah? Okay. Okay, so what about let's say I'm saying variance of AX plus Y. I'm saying X and Y are independent. Okay. From now onwards, I'm saying X and Y are independent. What about this case? If X and Y are independent,
times
Square variance of X plus
correct. So I
variance
will
variance
write
of Y.
variance of AX plus variance of Y,
Variance
right?
of Y.
And what about this? I will simply write A
A
square
square variance.
Square
variance of X
of X.
plus
Yes, sir.
variance of Y,
By
right? This is something I will
yes.
write, correct?
Yes.
And from
Yes,
where?
sir.
Okay. Tell me what, suppose I am writing variance of AX minus 1. Then I can apply this linear property, right? So simply it will be variance of AX, right? And
Plus.
what about plus or minus?
Plus.
Minus.
Okay. Okay, Y
Minus.
minus. Okay, basically it will be plus Y, I will tell you. So basically these things I can write variance of AX plus minus 1 times Y.
Okay,
Yes.
okay, sir. Yes, I got
So
it.
it will be variance of AX
Okay, okay,
plus
sir.
minus 1 square into variance of Y, right? So it will be variance of AX plus variance of Y, right? So this is not a correct. Okay.
So
So
Y
if you
minus
see,
1.
this is the one of the constant, right? You can't, okay. Can I write this minus? Oh, what do you mean by minus 1? That means something, I can simply say there is a minus 1 multiplied with Y, right?
Yes, sir.
Yes or no?
Ah, sir,
Yes,
correct.
sir.
Correct?
But
Okay.
this, how do you take
Yes,
V
sir.
suddenly?
Sorry? Okay. Let's do like this. Suppose I ask variance of 3x minus 4y. Now,
Case you can say minus 4. So
so
minus is
minus 4 has been multiplied with, okay. So, but I can't, okay. What you will do, I will give you the task. Just try this one. Variance of 3x minus variance of 4y. Whether this one is true or not.
Yes, sir.
Basically, here I will take minus 4 square. Okay.
Yes, sir.
So if you apply the property of this variability, so it will be variance of 3x plus minus 4. I mean,
Whole
it's
square.
nothing but let me write down clearly. So I can write this is variance of 3x plus I can simply write minus 4 times of y or not. Tell me. I can
Yes,
apply,
sir.
right? So that means what?
Yes, sir.
Variance of 3x, right? Plus variance of minus
Minus
4
4.
times y, right? So variance of 3x, that means 9 times of variance of x plus 16 times of
Plus
variance of
16
y.
Y.
Okay, so it always be plus. You can cross verify. This is not true. Why it will not be true? If you will find the variance of these two simultaneously, right? And just find the variance of 3x and subtract this, you will get the this equality will not hold. Okay, this is not true. I'm not going to do the proof
Sir,
here,
in
but
case if you give me a even number like minus 3y, minus 5y, it's also become plus, no?
yes, it's not about that. It's about any constant. Let's say I'm writing variance of 7 by 2x minus 5 by 3y.
Okay.
Okay. So this is any constant. So 7 by 2s, can I simply not write like this, or tell me, try mathematically. Is this true or not? Is this true or not?
Sir, it's true.
Right?
Yes, true.
Nothing.
It's true.
Yes, sir.
It's true for any constant. Simply you can say variance of ax minus by. I can simply write variance of ax plus minus b times of y. That's all. Okay. Since x and y are independent, I will simply write variance of ax plus variance of minus b times of y. Right?
So,
Okay. Yes.
so you're assuming that X and Y are like independent, but
Independent. Yeah. Independent. Yeah.
but
Independent.
does it matter that it is AX and BY? Does that change anything?
No. How will it will change? If those are independent, if I'm doing ax or x by a, it should not affect it, right?
Like, because let's say it's X plus Y. X plus
Hmm.
Y is different from 3X plus 2Y, right? Like,
But x and y are both different thing, right? X and y are independent. You are
yeah,
not making the change. Say whether, okay, suppose I'm saying 2x, whether y will affect?
uh,
No, right?
what I'm saying is like you're saying X and Y are independent, but I'm saying why are we taking 3X and 2Y as independent? If we are mentioning X and Y as
Okay, that's my question. Suppose I'm saying x and y are independent, right?
yes, sir.
Okay. If I will do any operation on x, let's say 3x, will it be effect on y? It will, again, it will both will be independent.
Yes, sir.
If I will do 3x and let's say minus 2 times y, will it affect?
No, sir.
No,
Got it.
that is that. Got it?
Yes, sir.
So here it will be, in general, it will be a square variance of x plus minus b square variance of y. So simply I will write a square variance of x plus b square variance of y. So be clear with these minor mistakes. In exam, we can simply, we are doing variance of ax minus variance of by, but this is not true. Okay, we have to take care.
Sir,
Okay.
So
Yes.
in general, we can
sir,
say
I have
that
a doubt.
Yeah.
Hello.
Yes. Yes.
Sir, can we think of it like this, that x is a random variable, so it has some variance which will always be positive. Similarly,
Positive.
we have
Yes.
y, its variance will also be
Always.
positive. So
Correct.
therefore,
Correct.
if we subtract or I mean
Correct.
add both of them, the variance will always come out to be
Variance should be
positive
positive.
of each.
Correct. Variance cannot be negative. Yeah, that's the correct. Great. Okay. So let's move with the this question. The this one, only two questions are there. So the variance of a number of tickets sold in a day in an opera theater is 25. Okay. If for each ticket sold the profit obtained is 25 rupees, then what is the variance of the profit obtained in a day in a rupees square? So I'm giving you some 2 to 3 minutes. Do let me know what is the answer.
तो तेरी गई लो नंबर छापना शुरू कर देता है।
Okay, anyone? If you are not getting the answer, you can let me know the approach itself.
Sir,
Yes.
sir, 15,625.
Okay, let me see. Yeah, this is the answer. How many of you got this answer?
Sir, I got wrong answer.
Okay, no problem. We'll see. Okay, how did you approach? What is the question given to us? Yeah, tell me who got 15,625.
25
Sir,
times P of X.
25 times
Whole
variance.
square.
Power 3.
V of 25x.
Square.
V of
Okay.
25x.
How did you decide this one?
Yes, sir.
For one ticket, profit is 25.
Hmm.
For n tickets, it is 25x.
Correct. Correct. Yeah, that's the main approach you have to identify. Okay, basically, what's given to us variance of the number of tickets sold in an opera theater is 25, right? So let's say X is denoting number of tickets sold. Okay, so X denoting number of tickets sold in a I mean in a day and in opera theater, right? Let's say X. So this X can be 1, it can be 2, it can be 3, and all, right? Yes or no?
Yes, sir.
Okay. So what is the question saying? Variance for each ticket sold, profit obtained is 25 rupees. Suppose one ticket has been sold, then what is the profit? 25. If two ticket has been sold, that means how much profit?
50.
That means 2 into 25. Yes or no?
Yes, sir.
If three ticket has been sold, that means
3 into 25
3 into 25. If four, then 4 into
and 4 into
25. Okay.
25.
So what about X number of tickets? It will be 25 times of
X.
right? So variance of, we have to find the 25 times of X. Now, if
X.
you will apply the, tell me, what about variance of 8 times X?
A
A
square
square
variance of X.
into variance of
A
X.
square
So it will
variance
be
of X.
25 square variance of X, right?
X.
25
X.
square is nothing but 625. And what is the variance of X? This is
25.
given to us
25.
25. So this is the
15,625.
clear. Okay.
Sir, if you will
So
do it in this way, like variance of x plus x plus x
yes,
25
that's
times.
also correct. You can do.
Sir, events are independent here or not?
No, it's a independent, right? It's a see. It's a how will it affect, right? Basically, okay, forget about independence. If simply here we are talking about number of tickets. It can be X is referring number of tickets. It can be 1, it can be 2, it can be 3, whatever, right?
Yes.
Yes.
Okay. Sir, if you will apply that rule, that is variance of x plus x plus x
That
25
means same,
times.
right? So you are see this is the only then you will get these things, right? Basically, what you are doing, variance of X, right? Let's say what about one time X1 tickets has been sold, right? Basically, then variance of X, right? You are doing this thing, is right? So here you are
Uh-huh.
talking about the same random variable, right? So I can add.
Yes.
Okay,
So the
not this.
variance of x is 25,
No,
right?
you are talking about here like this, X plus X, right?
Yes,
Not
yes,
this. This
exactly.
was incorrect. So basically, you are talking about 25 times.
But we can solve this in this way also, right?
No problem. This is the same way, right?
Okay, so if so that is why I'm asking whether it is independent or not. If it is independent, then we can apply variance of x into 25, right?
Variance of X.
No. But it's a confusion.
No, I'm saying if this x plus x, those events are independent,
Okay,
then
can you, okay, first of all, tell me whether these are the different events.
they are same events. So
They are same.
that is why they are dependent, right?
Okay,
Sir,
so first,
I'm saying that this if you will equate it to variance of x plus variance of x, that is variance of x plus y is what? That is variance of x plus variance of y. If events are
okay,
independent.
how did you find this one? First of all, tell me whether this will be true or this will be 25 times of X, 25 times of X, 25 times. No, one second. One second. Yeah, I think there is some. Okay. So as per okay, my approach is clear. The for
Yes,
one
sir.
ticket
Yes, sir.
profit is 25. For two tickets profit is 2 into 25, right?
Yes, sir.
Similarly, for X number of tickets, it will be 25 times of X, right? Now, okay. So this is we have to find the variance of 25 times of X. Now, how will you decide this? The way you are saying this, how you have decided till 25 times? That is my question. Tell me how you have decided this till 25 times. That is my question.
Okay, so
right?
So you came up with variance of 25x, right?
Yes, yeah. This is
That
something you are just expanding this one, but that's not the case here. Main question is I got 25. There is a meaning this 25x, right? This is the profit for X number of tickets, correct? What do you mean
yes.
by there X? How will you decide this only 25 has been sold, right? You have to associate profits also, right? Are you getting? Okay.
Yes, sir.
Yeah.
Okay, sir. Got it.
Right. So the last question is for from week 10. This is the I think this is also in the activity. Okay.
Sorry, sir, in the
So,
last question.
hmm?
Sir, isn't like I didn't get the question at all, but isn't it like variance of variance happening somewhere? Because X is like variance, right?
X is not a variance, X is your random variable. See, variance of this case is 25. So this whole is your random variable. Got it? So variance of number of tickets, your random variable X is number of tickets.
Okay.
Get it? It's a simple question. Suppose I am saying X represents the number of tickets sold in a day in a opera theater is 25. Okay, so this is X is representing only number of tickets. Variance of this number of tickets, that means variance of X is 25, right?
Yes, sir.
Okay, fine.
Yes, sir. Yes, sir.
Okay, so this is the last question. Okay, this question are from week 11. So this we will discuss in upcoming session. So this is the very last question from week 10. Okay, so just do it. Answer is coming out to be 5, but tell me how will you approach? Okay.
Sir, I get it done. Hello?
So do we need to explain this?
Yeah, sorry.
Sir,
Do
I
we
get
need
the answer.
to tell our approach?
Yeah, good, good. How did you approach for that?
Sir, me?
Yeah, anyone, no problem.
Sir, variance for X is equals to 2.
Hmm.
And variance of by, here given by is equals to 2x.
Hmm.
So it becomes 4 into variance of X.
Okay.
So, and variance of Z is equals to 7.
Hmm.
Then we get 25. So standard deviation is equals to root under variance. Then we get 5.
Yeah. Anyone else who wants to explain? Yeah, good. If you want to explain, no problem. You will get the idea whether you are
Y
correct.
value inside this standard deviation, and it becomes 3x plus Z.
Okay, first of all, standard. Okay, standard deviation is what? It's nothing but square root of the variance, right?
Variance, yes, sir.
And why we are taking
Yes, sir.
square root? Because if suppose X is something weight of person, right? Then your variance will be in kilogram square, right? And original
Yes, sir.
data will be in kilogram. So if I will take the square root of this, so I will get the variability in kilogram. So unit will be same, so it will be easier to compare with the original data set, correct? Now here standard deviation of X plus Y plus Z is nothing but I can write the variance of X plus Y plus Z, right? But
Yes,
if
sir.
you see, there is not information, means all three are not independent, right? Only X and Z are independent, correct?
Yes, sir.
Yes, sir.
So, okay. So I can't write variance of X plus variance of Y plus variance of Z, right? So, but I can, if you see what is the Y is nothing but 2 times of X, right?
Yes.
So if you see, this is variance of 3X
3x
plus
plus y, z.
Z, right? So variance of 3X plus Z, so if you see inside the square, what is the, now X and G are independent. This is the given to me. These are
Yes, sir.
independent. So I can simply write variance of 3X plus variance of Z. That means it will be variance of 3X means 9 times of variance of X plus variance of Z. Now it will be square
9
root
times
of,
2 plus 7.
I'm writing here itself. It's visible, right? Should I use
Yes,
any
sir.
other
Yes,
color? So it will be 9 times, what is the variance of X?
2.
2 plus
7.
variance of Z is 7. So it's nothing but 25 and the square root is 5. So 5 is the correct answer. Basically what we have done, question is the same, simple, but I just use the properties which we are aware about. Okay. Okay, is this clear? Expectation, variance and all PMF, CDF?
Yes, sir, it's
Yes, sir.
clear.
Okay, so these are the questions from distribution. So in the upcoming session, which are we will on Tuesday. So most probably
is-
Musa ma'am will take the revision session. If not, we will revise the content of week 11 and week 12. Okay.
Sir,
Can I explain 1 second that 9th question?
Okay. Yeah. Sure.
sir, is the slides are present on the portal?
These are from the activity, right? So these questions are from activity. We have taken from the activity just to cover up the main content, right? All the concepts. Yeah, someone
okay,
was
sir.
okay. Is this clear now?
Yes, sir, it's clear.
But how about
Sir,
3x?
Yes.
3x.
sir, can we do this variance of y equals to 4 into variance of x?
Yes, you can do, but thing is that how will you? Okay, you can't write here a standard deviation of.
No,
I
sir.
mean,
No, sir. Sir, I explained wrong, sir. Sorry,
yeah.
sir.
So actually, you can't
Sir,
write variance of x
yes,
plus
sir.
variance of y plus variance of z because see, if you see x and y are dependent, right?
Sir,
Yes.
yes,
Only
sir. Sir,
information about x and z are there. Means x and g are independent, right? Not about any y, right? Okay.
Yes,
Okay.
sir.
Okay.
Now
Clear?
clear, sir. Now clear.
Oh,
Yeah.
okay.
Thank you,
Thanks.
sir. Thank you, sir.
Okay. Thanks. Bye.
Yeah.
Yes, sir.
Good.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay. Thanks. Bye.
Thank you, sir.
Bye, sir.
Thank you, sir.
Good night, sir.